Good morning, guys. This is Mr. Kilburn, and I'm going to make a video for you to finish the notes so you can continue to work on the homework. So it's obviously not due today because I'm not here, but it will be due on Friday. So you're not here on Wednesday or Thursday due to state testing. And again, so 1 through 3, this will be your last grade for this marking period. Okay, so the bite force, the body mass and the bite force of a crocodile. So the line I drew here kind of best fits that data. So there's some points right on the line, some points evenly dispersed above it, below it. So it may not be perfect, but it's a pretty good line describing what's going on. So that answers question 2. Draw a line to represent the trend in the data. Comment on what you considered in drawing a line. Well, just that. Just made sure that some of the points are on the line, some points are above it, some points below it. And that's usually a good indicator that the line you drew is a line of best fit, or sometimes called the line of prediction. Okay, so it says, based on your line, predict the bite force for a crocodilian that weighs 220 pounds. How does this prediction compare to the actual bite force of the 220-pound crocodilian in the data set? Okay, so to use your line of best fit, I'm going to go to 220, so right about here. That's here. And then I'm going to go over, and it looks like it's about 850 pounds, 900 pounds of bite force, somewhere in there. But if you look back at the table, the actual value for a crocodile that weighed 220 pounds is right here, and it's 1,000. Okay, so again, it's a line of prediction. It's not an exact value. It's an approximation. Okay, so when we draw a line and we use it to estimate, it's an about. It's a prediction. It's not exact. Okay, next turn to this page, number 4. 4 students drew a line of best fit through some data based on what we've been talking about with the crocodiles. And so here's just some thoughts I had for these 4, and you can agree or disagree. I think these are pretty accurate, though. So Saul's line right here, it's a pretty good fit. All right, the data is evenly spread out above and below it. I think it could probably be a little less steep because you could almost draw a line that's at least hitting some of these points right here. At the bottom, they're clumped together. So not bad. Patty's line is probably really good because she did incorporate hitting these points down here, hit some points here, hit some points here, evenly spaced above, below. So that line is a line of, it's just accurately drawn. Marissa, not very accurate. Okay, the slope looks pretty close, looks pretty right, but again, aside from having a couple points on it, a lot of these points are below and none are above. And then Taylor's, again, not horrible, but should probably be a little bit steeper. Okay, so take a moment, and even if you need to pause the video, get these 4 explanations for the students on why their line was or was not a good fit. Again, pause it if you need to. Okay, next. So it talks about what is the equation of the line that we drew. Okay, so let's go back to here. All right, let me clear this ink out. So to get an equation for a line of best fit, again, this next part should sound kind of familiar. Taking 2 ordered pairs and getting the line of best fit. Okay, we've figured out the slope, figured out the y-intercept, and you've got your equation. So if I were to pick 2 points, I don't know, maybe, let's say this point here, and we'll say this point here. All right, so this one looks like it's about 325, I don't know, 1,200, which again means it weighs 325 pounds but has a 1,200-pound bite force. And right here, looks like it's about 35 pounds, and we'll say 250 pounds of bite force. So we're going to use these 2 points and calculate the line of best fit. All right, so 325, 1,200, 325, 1,200, and what was the other one? 35, 250. Okay, well, when you have 2 ordered pairs, whether it's 2 points or table of values or whatever, first thing you do is figure out the slope. That's an M. Okay, so you'd be 1,200. Come on. Subtract 250. all over 325, subtract 35. Okay, so subtract here, you get 950 all over 290. And let me see here, that works out to be 950 divided by 290. Call it 3.3. Okay, so that's the slope. And so now we need to write down a certain equation that you've written down a whole bunch of times. What is it? That's right. Y equals mx plus b. Okay, so 3.3 is going in for the slope. No, that's not right. Let's use 325 and 1200. Sorry it's taking so slow. This thing's super delayed. Okay. So we need to solve for b. 3.3 times 325, 1072. Uh, 1072. Boy, oh boy, that is slow. Subtract 1072 to both sides, and you get 128. Equals b. Okay, so there's your slope, there's your y-intercept, giving you an equation of y equals 3.3 x plus 128. Whew. Sorry that took so long. Okay, next. Okay, so it says, based on the scatter plot above, describe the relationship between the age and price of used cars. So I'm going to type to make this hopefully faster. But clearly, the price of the vehicle is decreasing over time. So simply that. The price of the cars decreases over time. Okay, it says Nora drew a line she thought was close to many of the points and found the equation of the line. She used the points 13, 6,000 and 7, 12,000 on her line to find the equation. Explain why those points made finding the equation easy. Okay, well, if you quickly found the slope, all right, you would get 6,000. Let's see here. It's a little faster. I'm just going to find the slope just so you see what the point they're making. You get 6,000 over negative 6. or a slope of negative 1,000. Right, so then it's pretty obvious that each year the value is decreasing $1,000. Okay, so that's why she picked those points. Just made finding the slope pretty easy. Okay, find the equation of Noah's line for predicting the price of a used car given its age. So all you would do at this point, and I'll leave this up to you, would be to pick 2 points. Maybe, I don't know, this one and this one, whatever, and determine the slope, determine the y-intercept, and get your equation. Okay, we just did an example like that. We've done plenty before. I'll leave that to you to do. This is based on the line for which car in the data set would the predicted value be furthest from the actual value. All right, so you're just looking for the data point that's furthest away from the line of best fit, which in this case hopefully becomes pretty obvious. No, not you. Here. Okay, it's what's called an outlier. You know, if you hear back in the old Western days of an outlaw, where someone's outside the law doesn't apply to them anymore. Basically, you can do whatever you want to them, you won't get in trouble. So this data is kind of far away from where most of the data is. So it's called an outlier. So that's what they're talking about there, is the data that's furthest away from the line of best fit would be that one. Okay, so now for the homework that is due Friday. Use this equation. When they ask you to find the predicted value, that's the equation you use. Okay, so for instance, for number 1, it says use the equation given, the one I just underlined, to find the difference, the observed value minus predicted value for the most expensive property and for the property that's 35 spaces from go. So again, the observed value is the actual value. Okay, so for right here, the actual value of the property that's 35 spaces from go is $200 right here. And for the place that's furthest away, 39, it's $400. So those are the actual. But you're going to use the equation to find the predicted. Okay, so plug a 35 in, plug a 39 in, and determine those. Okay, question B, or part B, says 5 of the points seem to lie in a horizontal line. What do these points have in common? So what do these points have in common? Besides the fact they're horizontal, I know that. But what do they have in common as far as the value is concerned? And what's that equation of that line? Pretty straightforward. And then C, 4 of the 5 points described in part B are the railroads. If you were fitting a line to predict price with distance from go, would you use these 4 points? Why or why not? Well, if you pick those points and drew a line, does that line best reflect the data? Obviously not, so explain that. Okay, number 2, you're taking this table and using it along with these 2 to fill in the next table right here. Okay, so put the independent values in this column, put the observed values in this column, use the line of best fit to fill in that. Okay, so for instance, the first independent value is 20 and the actual is 27. So the independent is 20, this is 27. Okay, so the response predicted by line 1 and then response predicted by line 2. So go to line 1 at 20. Okay, at 20, line 1 says it should be at 27. And line 2 says it should be at looks like 26. So this is how you fill in this table. And then you can answer B and C pretty straightforward. And lastly, for number 3, it's a matching. Which one's equation 1, which one's equation 2, which one's equation 3. If you look at the slopes, they're pretty detailed and they're pretty close together. Okay, so visually it'd be hard to tell which one's which, although If you look for the steepest, you should be able to figure out which one's which, or focus on the y-intercept to help you determine which equation is which. Okay, so there you go. That assignment is due Friday. Definitely getting graded. Definitely counting on third marking period. And I will see you on probably later third period tomorrow, but not for the first half probably. Okay, hope your day goes well. Take care. Bye-bye.